Welcome to my 270th video on my work with OO gauge. A bit delayed this one as I've been struggling with severe challenges on the household plumbing front, which kept me too tired and stressed to get back to working on this video. This video will feature a 3-rail kit-built model of an S&DJR 7F280 tender locomotive that I bought on eBay. The usual, a bit of background history, a look at the new model with some necessary servicing and repair, and some running video on my Hornby Dublo 3-rail tabletop. First, a bit of history. The 7F class of locomotive represented by this model was the largest and heaviest class of engine to come out of the Midland Railway's works at Derby, most definitely quite outside the Midland's general small engine policy. These exceptional engines were not created to run in general on the Midland's own lines, but rather were created specifically to operate on the Somerset and Dorset Joint Railway. The history of the Somerset and Dorset Joint Railway, the S&DJR, is far too complex to cover in detail here. You can see here a map of the lines of the S&DJR and their principal connections, basically from Bournemouth to Bath with a branch to Burnham-on-Sea. The critical factors of this railway leading to the creation of the 7F class by the Midland Railway are firstly that the S&DJR was a joint railway jointly operated by the Midland and the London and South Western Railway, and after amalgamation jointly by the LMS and the Southern Railway, and secondly, that the lines of the S&DJR were heavily graded, requiring a powerful engine to operate heavy freight trains, but also with some weight restrictions. Given these factors, a relatively free hand was given in the design of this class, although they did still use some standard Derby elements such as the axle boxes, which were prone to overheating, especially on such a large, powerful engine. 6 engines of the class were built in 1914, all going to work on the S&DJR. After amalgamation, in 1925, the LMS had 5 more members of the class built by Robert Stevenson and Company. The original 6 engines built in 1914 had small boilers, as at top in this illustration. The 5 built in 1925 were all initially fitted with larger boilers, as at bottom here, but several of them were later refitted with smaller boilers. My model represents a 7F fitted with a smaller boiler. In 1930, all of the 7F class were taken into general LMS stock and remarked as LMS engines rather than S&DJR, numbered from 9670 to 9680. When operated by the S&DJR, they were numbered from 80 to 90. In 1932, they were renumbered again by the LMS from 13800 to 13810. All of them passed into BR service upon nationalisation in 1948. As with other LMS engines, British Railways added 40,000 to the running numbers. Since the LMS used 5-digit numbers beginning with 1 for these engines, this resulted in BR numbers starting with 5. They were withdrawn between 1959 and 1964, with 2 of the second batch, 53808 and 53809, being preserved. Here's my model as it arrived, with the foam and tissue packing removed. This came from the same vendor as the 3-rail kit-built Patriot and 262 tank, which I've already featured in this video series, and I would assume that all 3 kits were built by the same person. Here is the model on the bench. This model was set up for 3-rail running, using centre-rail plunger pickups on the tender, as with Dublo 3-rail Castles and 8Fs. The model was not initially functional, as there was no electrical connection between the loco and tender, so the motor could not get power from the centre rail. The bands on the firebox had some kind of strip stuck over them which was coming loose. When I tried to put that back into position, it just crumbled, so I ended up removing it, leaving an exposed brass strip, which I thought didn't look too bad. As you may see here, there was some sort of wire coming out of the front of the tender, and there was a wire coming out of the back of the engine with just a very thin piece remaining on the exposed end. I tried the model by applying power from my bench power supply to the wheels and to the thin remains of the wire coming from the back of the engine. The motor did run like that. I used a bronze brush and a rotary tool to clean the driving wheels, moving them with power from the bench supply. I also cleaned the wheels of the pony truck, which were particularly filthy. I needed to disassemble the model for further work, so I started by undoing the screw holding on the front pony truck. I wasn't quite sure which screw or screws were holding body and chassis together. There was one likely screw at the front and a couple of possible candidates at the back. I undid the front screw. I wasn't at all sure about the back screws. It did look as if one of these might be holding on the body, but it turned out that only the front screw was holding on the body. I was able to remove the body by lifting at the front and then pulling the chassis forward. The screw in front of the drawbar connection at the back, which I did loosen, turned out to be holding on the motor by going through the bottom pole piece in front of the magnet. This is an unusual arrangement. Normally a motor of this type would be held on by a screw behind the magnet at the back, but in this case the magnet is actually hanging off the back of the chassis, so clearly an alternative place for the motor attachment screw was required. The motor was of an XO4 type. It's a bit tricky to make out how the connections work from this picture. The far brush is held in place by an uninsulated spring, which should connect it to the chassis. Perhaps this connection was initially not working well, as a bare wire has been soldered between the arm of that spring and a folded brass piece fastened underneath the nut holding on the spring. The wire coming from the back of the engine is not connected to that brass fastening as might at first appear. The wire passes through the brass fastening and is then connected to the black electrical component at left. Not entirely sure what that is, but I think probably a resistor. The other end of that component is connected to the green wire, which is in turn connected to a metal sleeve on the insulated end of the other spring arm, and so to the other motor brush. There is another electrical component, presumably a capacitor, soldered between the arm of the spring and the connector on the end of the green wire, so bridging across the two brushes, presumably for RF suppression. I unhooked the ends of the spring from the brushes. The connections are actually perhaps clearer in this picture. I removed the brushes so that I could check and clean them and get at the commutator to clean it. I got out some original T-cut to clean the commutator. The commutator was rather scored and I couldn't get it completely clean. I got out some electrical contact cleaner to clean the brushes and contacts. I used some gear oil and white grease to lubricate the worm and drive gear. I oiled all of the pivot points of the motion and the axles. My oil dispenser is bandaged with duct tape as I squeezed it too hard and cracked it. The valve gear and motion on this model was particularly complicated, with actual moving valve rods. I cleaned the wheels of the tender with a bronze brush and a rotary tool. I got hold of the electrical tape on the end of the connection from the front of the tender with the intention of removing that tape, but it turned out that tape was on the end of a plug which came out of the socket on the end of the wire from the tender. I tested for electrical continuity between the centre rail plunger pickups and the socket on the end of the wire. I didn't initially seem to find continuity, but perhaps I wasn't making good contact. I looked at the bottom of the tender to see how it might be disassembled. There were 2 screws, and I assumed that the screw at right here was likely to be holding on the body. And indeed, when I undid that screw, the body came off. The body was clearly built from a brass kit. I undid the other screw. This allowed the lower chassis with the wheels and the coupling to be detached, leaving the upper part of the chassis with the plunger pickups. The wire coming out of the front of the tender was connected to both plunger pickups on the bottom of this section. I tested again for electrical continuity. This time I did find continuity between both plunger pickups and the socket on the end of the front wire. Here's the plug that I removed from the socket on the wire at the front of the tender. And here's that plug with the electrical tape removed. Clearly, that plug was supposed to be on the end of the wire coming from the back of the loco, allowing the wire from the loco to be connected to the tender wire, and so get power from the centre rail. So it looked as though I should be able to get things working if I could re-establish that connection. The remaining wire didn't seem to be long enough to really allow for proper reconnection, so I unthreaded it from the folded brass connector. And then I unsoldered its end from where it was connected to the resistor. I cut a new piece of thin black wire, just a bit longer than the remains of the original wire, and stripped and tinned the ends. I soldered the plug onto one end of that wire. Then I put a piece of heat shrink over the end to insulate the connection and the back of the plug. I threaded my new wire through the folded brass connector. Then I soldered its end to the resistor. I tested with my bench power supply connected to the plug and to the wheels. The motor did run okay. I reassembled the pieces of the tender. I plugged the wire from the loco into the socket on the front of the tender. I tested with power to the loco wheels and the plunger pickups on the tender. The motor ran okay. I refitted the loco chassis into the body. There seemed to be 2 holes that could possibly be used for connection of the front pony truck, and I couldn't remember which one it was in when I took it off. It appeared that the back hole had clean threads, so presumably that was the one used. I reattached the pony truck. I coupled up loco and tender and plugged in the connecting wire. I got the model onto my Dublo 3-rail tabletop for an initial running test. Okay, let me see if I can do an initial running trial with this Kit Built 7F. I'm going to do it on the MNRC sound and power controller because I did do it on the... I was doing it on the Gauge Master and it did go on the Gauge Master, but that's about 50% on the sound and power. It's very sort of noisy, although I did lubricate it. I don't know what that noise is coming from. It's making dubious noises. Yeah, so I think we should have a bit more servicing. It's going. I might have remade the connection, and it may be set up to be geared very slowly, because it is, after all, a freight locomotive. But it's a bit, it seems to me, excuse me, I gotta bend down, whoa, see I have to bend down to reach that controller because it doesn't have a remote. Okay, so it's going, but it could do with more servicing, I guess. And then of course I want to clean up its appearance and remark it as in LMS service, but I think it needs a bit more servicing first. The model ran more or less okay, although it took quite a bit of power and was rather noisy. I took the Loco chassis out of the body again and lubricated the bearings of the motor, which I'd forgotten to do before. This did make the model run more quietly. Well, that's running at 60% or so on the bench controller, which is usually about what I set the bench controller at. And it's quieter. I've oiled the motor bearings now, which just seem to have quietened it a fair bit. You know, maybe that's acceptable running. It's a little slow, but I don't know whether you're going to do much else. I mean, I've already oiled all of the linkages and the axles. No, I didn't take the axles apart and whatever. And that's running almost acceptably now, isn't it? Having got the model running acceptably, I turned my attention to remarking it for LMS service, as my preferred prototype is LMS operations before the Second World War. Microset will do a good job of softening and removing water slide decals, so long as they haven't been covered with an overcoat, but it didn't seem to have any real effect on the BR markings on the tender. The microset did make the running numbers on the cab sides come apart a bit, but even with a lot of rubbing I couldn't get the rest off. I didn't even try methyl hydrate, as I'm pretty sure it would have just stripped the paint right off the brass. Instead I painted over the BR markings with flat black paint. Here are Loco and tender after that paint dried. Examining old photos of 7Fs in LMS service, it seemed to me that plain straw markings were likely used, so I got out some appropriate press-fix decals. I put a piece of masking tape on the cab side to help me align the digits of the running number. When I received the model, it was numbered 53804, which would make it the fourth of the original batch built, with a small boiler in 1914 and withdrawn in 1962. I decided that I would renumber it as 13809, the number given by the LMS in 1932 to one of the two 7Fs now preserved. Here is that engine in British Railways service as 53809. This engine was initially built with a larger boiler, but it was refitted with a smaller boiler in 1930, so it always had a small boiler whilst bearing LMS markings. One other Loco 9680, originally 90, later 13810, and even later 53810, also received a small boiler in 1930. The remaining three engines with larger boilers retained those boilers throughout LMS service, but they did all have their boilers replaced with smaller ones in the 1950s. Here is that engine in preservation with LMS markings. That is 13809, the one I chose to mark as. The markings here appear to be of the shadowed yellow type, I think, although it's a bit hard to see, but of course this isn't historic evidence of actual LMS service anyway. Here is the other engine that was preserved, 13808, in actual LMS service in the 1940s after the war. I did my best to line up the digits for the 13809 number on the cab side. And here is that number with the backing and tape removed. I put LMS lettering onto the sides of the tender. And here is that lettering with the backing removed. I applied a coat of clear matte acrylic fixative to protect the decals and smooth out my brush painting a bit. I reassembled Loco and tender, and tested to make sure that things still worked on the bench. Finally, I got the model back onto my 3-rail tracks for some more running. Okay, so now this kit-built 3-rail SDJR 7F is marked in LMS markings as it would have been, well, actually after 1932, because it would have been marked in LMS markings in 1930, but with a different number, a 4-digit number beginning with a 9, and it was renumbered to this number in 1932, so and so it would have been like this more or less from 1932 until it became a British Railways engine. Let's see if I can run this. I'm going to run it on the gauge master controller, though it's fairly high on the gauge master controller. It needs rather a lot of power. But yeah, it's about 90% on the gauge master, which is a bit high. 85. Yeah, it's a bit much, but it's a freight engine. 80. That's 80 on the gauge master, which would be what? Oh, I don't know, 45 or something on the 40-45 on the MRC sounding power. Okay, well that seems, famous last words, to be working more or less. Let's see if I can hook a freight train up to it. Might be a bit tricky, but we'll see what we can do. So here he is, hooked up with a little freight train. It's not a big train. You know, 3 wagons and a tank, and hesitates a bit going over that point for some reason. I tried cleaning the point. I spend a lot of time trying to clean track and things. There's the engine, whoops, falling over. It does tend to hesitate a bit there. Yes, 3, an empty open wagon, a box wagon, 2 box cars, and a trailer, and I think they were all made by Hornby. And the back 4 have got metal simplex couplings. The open wagon is a later super detail one with the Hornby Dublo plastic couplings. And this is running, turn it down here, but this is running about 85 on the gauge master controller. Okay, well I think I'm going to stop it at that, really. You know, I mean, what you going to do? He's moderately successfully done, and I'm really quite pleased with him on the whole.